application of differentiation. They're saying differentiation plays a central role in economics, especially in analyzing how economic variables change and how to make optimal decisions. We have what we call marginal and average functions. And then they're saying that the rate at which total revenue, which is TR, changes is called marginal revenue. And the rate at which your total cost changes is called a marginal cost, which is MC. And then you'll see there we have it. The marginal revenue is equals to the derivative of total revenue. And then the marginal cost is equals to the derivative of total cost. And then please remember that your total revenue is equals to P times Q. And then your total cost is equals to FC plus VC. Please mute your mic. Okay. And then they're saying here, marginal revenue is defined as additional income that is generated from the sale of one more unit of goods or service. Okay. And then the marginal cost refers to the increase or decrease in the cost of producing one more unit or saving one more customer. And then we have an example there. The example says, given the demand function, P is equals to 6 minus 0.5 Q, find the value of marginal revenue, which is MR, for Q is equals to 5. So firstly, we have to find the marginal revenue, and then we said that the marginal revenue is the rate at which your total revenue changes. So we are going to have, so before I write, I want to remind you that don't forget that every time we derive the derivative of, I'm just going to write it here, derivative of x to the power of n. Don't forget that we said that this is n, then x, then n minus 1. And then now we are going to derive our total revenue. So remember we said that total revenue is equals to P times Q. And then we have our P. Our P is 6 minus 0.5 Q. And then this will be times this Q. And then now we are going to multiply. So we multiply everything with Q. You are going to have 6Q and then minus 0.5 Q squared, because Q times Q is Q squared. Q times another Q, you get a Q squared. That's why we have the Q squared. So this is our total revenue. Our total revenue is that. And then now we can find our marginal revenue. We said that is going to be the derivative of our total revenue. So we are going to derive our total revenue. So our marginal revenue is going to be equals to, let me just say therefore, my marginal revenue is going to be the derivative with respect to Q of 6Q minus 0.5 Q squared. And then when we derive, I said that we are going to say n then x to the power of n minus 1. That's what I'm going to do here, just to remind you. So we are going to have, I'm just going to use brackets for the 6. I am going to have 6. Remember, I said that there's always a 1 here. There's always a 1 here. So this means it's 6 times 1, and then Q, and then to the power of 1 minus 1. I'm just doing this so that you can remember. And then minus, I'm deriving each and every one of them. Minus, then it's 0.5. And then 0.5 times 2 times this 2. And then I have my q to the power of 2, then I have to minus 1. You always have to minus 1. And then we are going to have, now we can solve. 6 times 1, we are going to have 6. So this will be 6. And then q, and then 1 minus 1, we get 0. And then minus, and then 0, comma.
Sorry, interrupt you. Can you just up the page, please?
Sorry?
Can you up the page? I didn't see the others.
Yeah, I'm going to upload this. I'm going to
Yeah.
upload it under lessons.
Thank you. Okay, thank you so much.
Okay, so this is going to be 0, 0.5 times 2. We are going to have 1, and then q, and then 2 minus 1, we are going to have 1. And then this is 6 minus q, because 1 times q is q. We said that, please remember that q to the power of 0, q to the power of 0 is 1, just in case you're wondering. And then now, just to remind you, and then now we go on. So this is our marginal revenue. So our marginal revenue is going to be 6 minus q. And then now we move on to number 2. Please mute your mic. Please mute your mic.
Ma'am, we didn't
Sorry,
finish.
ma'am, can you please go up a bit?
Can you please mute your mic? Okay. All right. And then we go to number 2. Number 2 says, given the total cost function, this is the given function. They're saying that derive the equation for marginal cost. So we're going to derive the equation for marginal cost. So we have a total cost. You cannot find your marginal cost without the total cost. We need to find the derivative. So we are going to have, Michelle, your hand is up.
On the marginal MR, are we not supposed to substitute the Q?
No. Which Q are you going to substitute here?
Here,
Oh,
when they
here.
say for
Oh,
Q is
sorry.
equals to 5.
Yes, sorry. You're right. I forgot that. Thank you. So we are going to have okay, yes, you're right. Thank you. I didn't see the last part. Okay, yes. So it says we must find the value of marginal revenue for Q is equals to 5. So it means that wherever we see Q, we substitute 5. So we are going to have our marginal revenue, where our Q is 5, we are going to have 6 minus the 5. Thank you. And then our answer is going to be 1. Yeah, thank you. And then now we can go to number 2. Number 2 says, given the total cost, derive the equation for marginal cost. So now we're going to look for marginal cost. So it means we must find the derivative of total cost. So it's going to be our marginal cost is going to be equals to the derivative with respect to Q of 1 over 3 Q cubed, then minus 8Q squared, and then plus 120Q. So now we are going to find the derivative. So remember, when you differentiate each and every one of them. So I'm going to start with the 1/3, this term. So I am going to have, I'm going to use brackets. So it's going to be 1/3 and then times the 3. And then this will be q, then to the power of 3, then minus 1. Remember, we said that you have to minus 1. And then we are going to have, that's the first one. So what I did here, I did it for the first term. Then I'm going to do it for 8 now. So it's minus, minus. And then for 8, it's going to be 8. And then times 2, the exponent 2, times 2. And then q to the power of 2. Then I minus 1. You always minus 1. And then now we are doing it for 120q. We're differentiating 120q. So it's plus, plus. Then I'm going to use a bracket again. So remember, there's a 1 here, but it's always there. So it means this will be 120 times that 1. 120 times 1. You don't have to say times 1. I'm just doing it so that you can understand. And then this is q, then to the power of 1 minus 1. 1 minus 1. You always minus 1. And then now we are going to solve. You don't have to write this step. I'm just doing it so that some of you can understand. So 1/3 times 3 is 1. So this will be 1. Then q, and then 2. 3 minus 1, it's 2. And then minus, minus. Why am I putting brackets? Minus, minus. And then we come to this one. 8 times 2 is 16. Please mute your mic. It's 16. And then this is q. And then to the power of 2 minus 1 is 1. And then plus, plus, you don't need to write the 1. And then this is 120 times 1 is 120. And then q, 120 cube. And then 1 minus 1 is 0. And then this will be q squared minus 16q. There's no need to write the 1. And then plus 120. Remember, I said that q to the power of 0 is 1. I'm going to write it so that you can remember. Q to the power of 0 is equals to 1. And then 1 times 120 is 120. And then that's the answer for our marginal cost. And then we move on to, okay. And then now we're going to move on to average revenue and cost function. Is there a question under number 2? Okay. And then we move on to our average revenue. So they're saying average revenue is defined as the average revenue per unit for the first Q successive unit sold. So the formula for our average revenue, it's TR over Q. Yes, Caesar?
Sorry, ma'am. I just wanted to go back. I'm so sorry. I was doing the calculations along with you, but then I was trying to trace back where I went wrong with number 2. So I don't know. After the second step, after the second to last step, which is the last step in Q to the power 2 minus 16 Q plus 120. We're not supposed to say 1 multiplied by 2 Q to the power 1 minus 2 minus 1. I'm not sure if I got it wrong.
No, we already did the minus 1 here.
Okay, where is that?
If you can check the first step, step here. I already did the minus 1s. I said 3 times 1/3 minus 1, it's here. 2 times 8 minus
yes, I'm
1,
fine
it's
with
here.
Yeah,
Yes, you can minus again.
Oh,
You can minus
okay.
again here. You do it only once. If you are doing it
Oh.
again, it means you are doing the second derivative. This is only the first
The first
derivative.
derivative. Okay. All
Yes.
right.
So if you are doing it for the
Noted.
second time, it means you are doing the
Okay.
second derivative. Yes.
Perfect. All right. Thank you.
Okay. All right. Okay. So we have the formula for average revenue. So it's total revenue over Q. And then also our total revenue can be equals to your average revenue times the Q. And then they're saying average revenue is equals to the price where P is the given, sorry, P is where is equals to P, sorry, where P is given by demand function. Meaning where your P is this. So let's see. And then average cost, the formula is this one. You can also say the total cost is equals to the average cost times the Q. This happens when you are given the average cost. That's when you can calculate the total cost with this formula. And then we have an example here. The example says, given a perfectly competitive firm's demand function, P is equals to 20. Expressions for the marginal and average revenue functions. What did I say here? So I think. Okay, no, this is the. All right, forgot the question here. I think it's right. Find expressions. Yes, the word find is missing here. Okay, it must be the same as this one. Okay, so it says find expressions for the marginal and the average revenue functions. So we're going to start with the total revenue. I hope that's the right word. Total revenue. You can't find the marginal revenue without the total revenue, if you remember. So we start with the total revenue. Total revenue, we know that it's P times Q, and then our P is 20, so it means this will be 20 Q. And then after we find our total revenue, now we can look for our marginal revenue.
Sorry, ma'am, you say total revenue, but you wrote total cost.
Thank you. Yeah, total revenue. Thank you. Yes, thank you. And then now we can look for our marginal revenue, which is the derivative of total revenue. So we are going to have marginal revenue is equals to the derivative with respect to Q of our total revenue. And then the answer here is going to be, I'm going to do it the longest way again. So this is 20. Remember, there's a 1 there. I repeat, there's a 1 here. So it's just 20 times 1. There's no need to say times 1. I'm just doing it so that we can be consistent. And then this is 1 minus 1. This is how we use the derivative. And then we are going to have 20 q to the power of 0. As I said, q to the power of 0 is 1. So our answer is 20. I'm only doing it the longest way so that we can understand, some of us. And then now we're going to do the average revenue. The average revenue, remember we said that the formula for average revenue is equals to the total revenue over Q. And then this will be total revenue, we got 20Q, then over Q. And then when we divide this, the Q and the Q, they're going to cancel. These two are going to cancel. And then we are going to have 20. Our answer is going to be 20. And then it means that our P is the same as the average revenue, which is the same as our marginal revenue. And then that's that. And then now we go to B. Okay. B, the given, sorry, given that a monopolist has a linear demand function, P is equals to 50 minus Q. They're saying find expressions for the marginal and average revenue functions. So we cannot get the marginal revenue without, please mute your mic, without getting the total revenue. So you're gonna do it again. If you didn't get it the first time, now you should be getting it. So we start with total revenue. Total revenue is equals to P times Q. We already have our P. Please mute your mic. Please mute your mic. Total revenue is equals to P times Q. Please mute your mic. And then our P, it's 50 minus 2Q. And then this is times Q. We are going to multiply. So you multiply everything by Q. So this will be 50Q. And then minus 2Q squared. This is our total revenue. And then for us to get the marginal revenue, we are going to find the derivative of total revenue. So therefore, my marginal revenue is equals to the derivative with respect to Q of total revenue, which is 50Q minus 2Q squared. I'm going to do it the longest way again so that some of us can understand the derivative because we need to know how to derive. I'm going to do it the longest way. You don't have to do it. So we are going to have, when we derive, we're going to have, I'm going to use brackets for 50Q. So it's going to be 50. Then times, remember I said there's always a 1 here, but we never write it. There's a 1 here. So it's going to be times that 1. And then Q to the power of 1 minus 1, we always minus 1. So it's going to be 1 minus 1, 1 minus 1. That's for 50Q. And then after it's minus, minus, and then I'm deriving the 2Q squared. So it's going to be 2. Then you multiply it by the exponent. So you're going to say 2 times 2. It's the same thing I did here. I said 1 times 50. So it's 2 times 2. Same thing. So it's going to be times 2. That's how we derive. And then you write the Q. And then to the power of 2, then minus 1. You always minus 1 on your exponents. And then we are going to have, now we can answer. So 50 times 1, it's 50. And then Q, then 1 minus 1 is 0. And then minus 2 times 2 is 4. And then it's Q, then 2 minus 1 is 1. Again, I said that Q minus 0, so the Q to the power of 0 is 1. So I am going to have 50, then minus 4Q. So this is my marginal revenue. And then now we are going to do the average revenue. So average revenue, we know that the formula says average revenue is equals to total revenue divided by Q. And then now we are going to substitute our total revenue. It's 50Q. 50Q minus 2, then Q to the power of 2. And then everything over, and then Q. And then here, every time you see a fraction like this Q belongs to this 50, and then it belongs to this term 2Q squared. So we are going to distribute the Q, like give it to everyone, don't distribute. So this is going to be 50Q, then over the Q. We share this Q, and then minus, minus. And then this will be 2Q squared over, it also deserves this Q. So this Q at the bottom, it belongs to 50Q and also 2Q squared. So that's why we split it. And then now we can divide the way we divided before. So now I can divide. I said that when we divide, the Q and the Q are going to cancel. So this Q is going to cancel this one. And then the 1 here will cancel the 1 here. You'll be left with 1. Because Q squared, it means I have 2 Qs. So this is going to be 50 and then minus 2Q. Why? Because I'm going to write it down here. so that you can remember. I am saying that if you have Q squared over Q is the same as Q times Q, then over Q. So these two Q's are cancelling. That's why we are going to have only one Q left. This Q cancels this one. That's why your final answer is Q here. I'm writing it so that you can understand. I saw a hand. I saw a hand. Can you please ask your question?
Sorry, ma'am.
No, just
Yes.
there, ma'am. Like, what is
Okay.
okay?
Yes, next I saw there's another hand. Oh, you wanted to ask, is it fine?
I just wanted to ask, ma'am. So the Q that we are using to divide, it will be always as Q, or it will be sometimes have to be substituted as a number, or
No, it's Q. Remember this Q, we get it from the formula. The Q that we just used is from here. AR is equals to TR over Q. It's always there at the bottom, if you can see. It's a formula. Remember, these are formulas. This
What-
comes
what am-
from this formula. This formula. So there can't be a number here because the formula says it's Q. Do you understand?
yeah, I understand.
Yes, because TR, we got it from here, right? This is my TR. And then I substitute my TR, which is 50Q minus 2Q squared, then over Q, because my formula comes with the Q. All of them, they come with the Q.
So it will always be a Q.
Yes, it can't change because it's a formula.
Okay, thank you.
Yes. So this is your TR. This is the TR that we used. We used it here. And then please mute your mic.
Excuse me, before we
Yes.
go. If you can scroll up a little bit, I think I understand where that question comes from. Just scroll up from where we started there. Top. Okay. I think. Okay. Scroll up again. There's a part that there was a given value.
There was no, we are not using this. It was not average revenue.
No.
It was here. You're talking about this one, eh?
Yeah, no.
Is it the
I
P
think,
is equals to?
Yeah, where it was say Q equals to 5. I think he was asking if there will be the time that Q has been given a value.
No, remember here that we're saying find the value of what? We're looking for the value of the marginal revenue. So if I want the value of the marginal revenue, it means that I'm going to replace wherever is after I do everything, my final answer, wherever I see Q, I am going to put that 5. That's when we want the value of the marginal revenue. This is a function, right? So here, we were looking for, they didn't say they want the value. If they want, you see, we are saying that find expressions for marginal and average revenue function. So we're looking for a function. A function is not always a value. You see, a function has a Q. A function has a Q. Can you see? But if I said I want the value of the average revenue, it means that I must give you the value of Q so that you can substitute it here to give me the value of the average revenue. So this is a function, and also this one is a function. Do you understand? Okay. All right. And then we go to C. We go to C, and then C, they're saying find an expression for marginal cost function given the following average cost function. So now we're given the average cost function, and then we have to look for a marginal cost. You cannot look for a marginal cost function if you don't have the total cost. Remember, the marginal cost comes from the total cost. So I must look for my total cost first, and then I can look for my marginal cost. So please, okay. Which one is this one? Let's see. Pule, your hand is up.
Can you
Pule,
hear
your
me?
hand is up. Yes, I can hear you.
Okay. So, do you mind if maybe you give us like 10 minutes and you try it by ourselves, because it's like you're spoon feeding us.
No, you'll try with the activities. Remember, you have an activity. I'm only doing examples so that when you do activity, it's easy. So you will use this to do your activity. Remember here, I'm recording, so I can't pause. I can't pause for maybe 10 minutes. Do you understand? So the ones that I'm doing here, they're not part of the activity. So I'm doing this so that you can be able to practice with the one in your activity. I don't know if I make sense. Because if I pause, remember I'm recording and I need to post this video. Yes, Tobani, and yeah, I saw a hand up. Yes, you can ask. I see your hand is
No, ma'am.
up.
Oh, everything is clear. I'll just check up that number B, but I'm fine now. You can continue.
Okay. So, Pula,
Mm.
I'm recording, so I can't pause for 10 minutes. I need to pause the video. So, yeah, I'm sorry. And then remember we said that the total cost is equals to your AC times Q. Because we are given the AC, we cannot look for the marginal cost if you don't have the total cost. And for us to get the total cost, we're going to use this formula that they gave to us. So we are going to have our AC, we have 3Q squared minus 4Q, and then plus 6, and then this is plus 100. Sorry, this is plus 100 over Q. And then this is times this Q. So now we are going to multiply. You multiply everything with Q. Remember, when you multiply Q times Q, it means it's Q squared. I'm just going to write it here so that you understand. Q times Q is going to be Q to the power of 2. And then let's say 2 over Q times Q is going to be 2. Why? Because they cancel. I'm just doing this so that you understand where I'll be getting my answers. So this is just Q. Then I'm going to continue. So I'm going to multiply 3Q squared times Q is going to be 3. This is going to be 3Q to the power of 3. Because I multiplied. Let me just write this here. Because I multiplied. So my Q's now they'll be 3. And then this will be minus minus. Then 4. This will be Q. Q times Q is Q squared. I'm just doing this so that you understand. And then plus 6 times Q is going to be 6Q. I'm just doing this so that you understand. And then plus, now this 100 over Q times Q, I said is going to be 100. I showed you there. This will be 100 because the Q's, they're going to cancel. So this will be 100. That's how we did it. Hence, I did this so that you understand. And then now we have our total cost. Now we can look for marginal cost. Marginal cost is the derivative of your total cost. So my marginal cost is going to be equal to the derivative with respect to Q of 3Q to the power of 3 minus 4Q to the power of 2, then plus 6Q, and then plus 100. Caesar, your hand is up.
Thanks. I wanted to know with the expression, because it's in a fraction formula, the 100 over Q, is it not prudent maybe to first invert it to be 100Q to the power 1, the invincible 1, and then multiply?
It's the same thing. So this
Okay.
will be, let me write it here for you. 100 Q to the power of negative 1 times q is going to give you 100 q to the power of -1 plus 1. Remember, we add exponents. So this answer will be 100 q to the power of 0. And we said q to the power of 0 is what? Is 1. So your answer will be 100. That's why I did it in a fraction form. Because if I did it this way, it was going to take too long. Because I will have to show people how I got to the 0.
All
So
right. So
this
it's
is
just
what
that some of us have managed understood it to be, you first invert the fractions to be in a form as you've just put it in the dot bubble there, and then
Yes.
afterwards you multiply. But I think I get it. Thanks.
Yes. So normally I would do this if I didn't have to multiply with q. If it was just 100 over q, I would change it to be 100 to the power of -1, because when you differentiate, you don't want fractions. You want your q's to be at the top. That one I agree with. So here I just wanted to end up having my 100 without having to do it this way. But you're also right. Okay. And then now we can differentiate. So we start with this one. It's going to be 3. Then I said you multiply 3 times the exponent 3. And then q. I'm just doing this so that they can be consistent. Then it's going to be 3 minus 1. So that you understand how we differentiate. So you do it one by one. Then now we go to 4. So it's minus. Now we're going to go to 4. So it's going to be 4 times 2. 4 times 2. And then q. And then 2 minus 1. You always minus 1. And then it's going to be plus. And then this is 6. And then times. I said there's always a 1 here. There's no need, but I'm just going to do it so that they can be consistency. Then there's 1 q, then to the power of 1 minus 1. And then the other one, the derivative of 100 is 0. So this will be plus 0. The derivative of a constant is 0. So that's 0. And then now we move. 3 times 3 is 9. And then q, 3 minus 1, sorry, it's 2. And then minus 4 times 2 is 8. And then q, 2 minus 1 is 1. And this is plus 6 times 1 is 6. Then q to the power of 0. And then this will be 9q squared minus 8q, and then plus 6, because q to the power of 0 is 1. And then that's our marginal cost. That's how we get our marginal cost. And then now we go to Roman figure 1. From the answer that we got, they're saying that state from C, we need to state the value of a fixed cost and a variable cost. So if you can remember the first lesson, if I'm not mistaken, or unit 1, we know that, or unit 2, we know that total revenue, okay, let me write the total revenue that we have. Total revenue that we have from here is 3q to the power of 3 minus 4q squared plus 6q plus 100. And then if you can remember the formula for our total cost is supposed to be equals to your variable cost plus your fixed cost. And if you can remember, the fixed cost is always a value. It doesn't have q. Our fixed cost doesn't have q. It's always a value, if you can remember. So it means that from this function, 100 will be our fixed cost. Then the rest will be our variable cost. So from our total cost, our variable cost will be 3q 3q cubed. So our variable cost is going to be 3q cubed minus 4q squared plus 6q. And our fixed cost will be 100. And then now we move to Roman figure 2. Sorry. Roman figure 2, it says from there, calculate the value of marginal cost when Q is equals to 50. So this is what we're talking about. They will tell you if they want the value of the marginal cost, that's when you substitute the Q. So we are going to have our marginal cost. Remember, our marginal cost is 9q squared minus 8q, then plus 6. So if we want it at 50, so marginal cost will be 9. And then wherever we see q, we put 50. So this will be 50 squared. I'm sorry. This will be 50 squared. Sorry. So this will be 50 squared. And then minus 8. Then wherever we see q, we put 50. And then plus 6. And then your marginal cost will be, what will be the answer?
22,106.
22,106. So that's your marginal cost when your Q is 50. Sorry, I need to take this up. This is when your Q is 50. Okay. And then now we go to production functions. So that it is the question here before I move to production. Okay. Production functions shows the relationship between inputs used in production and the output produced. And then we have marginal production of labor, and then we also have average production of labor. And when you say that production of labor, marginal production of labor is the change in output that results from employing an additional worker. So that's the formula for marginal production labor. It's MPL, and then it's the derivative of that with respect to L. And then the average production of labor is a measure of the average amount of output each worker can produce. So that's the formula for average product of labor. Okay, what did they say? Okay. Sorry. And then now we have an example here. Okay. So there's an example that says given the short run production Q is equals to 5L squared minus 0.5 L cubed. Remember, L stands for labor. And then we are going to number A. They are saying deduce the equation for marginal production of labor, MPL. Then calculate and comment on the marginal product when 10 units of labor are employed. So we're doing the same thing over and over again. So we are going to look for, so we have our Q, our MPL, marginal product labor, is equals to the derivative of Q with respect to L. Our Q is 15 L squared minus 0.5 L cubed. And then now we're going to do the same thing. We're going to derive. So when we derive, I'm going to do it piece. I'm going to start with 15L squared. I'm going to have 15. I'm going to do this until you understand. So it's times 2. Then L to the power of 2 minus 1. Doesn't change. L to the power of 2 We always minus 1. This is how we derive. And then minus, then 0, 0.5. 0, 0.5, so it's going to be times 3. 0, 0.5 times 3. And then L to the power of 3 minus 1. We always minus the 1. Minus 1. And then this is 15 times 2 is 30. And then L, and then 2 minus 1 is 1. Then minus, then 0, 0.5 times 3 is going to be 1.5. And then L, then 3 minus 1 is 2. So this is our marginal product labor. So now they said that calculate the marginal product when 10 units of labor are employed. So when our L is 10 units. So when L is 10 units, now we want to know, so when L is 10 units. When L is 10 units, then we are going to have, so wherever I see L, I'm going to put 10. So this will be 30, and then times 10, and then minus 1.5 times 10 to the power of 2 times 10 to the power of 2. Can you please assist with the answer?
150.
So we are going to have 150. 150. So this means that production, so production is increasing. At the rate of 150 units per additional unit of labor. Additional unit of labor. So that's how we calculate the marginal production. Sorry. That's how we do the calculate the marginal product of labor in the equation. So there's the function, and then you substitute to get the product when you have, yes, 10 units. And then now we go to B. So B, they're saying derive the equation is Angela.
Good evening, ma'am.
Good evening.
So basically, if it was minus 150, so you were going to say production is decreasing at the rate of 150 units per additional unit of labor, right?
Yes.
Okay, thank you.
Thank you. Okay, and then so they're saying derive the equation of the average product of labor, so APL. So they're saying calculate and comment on the average product for the first 10 units of labor. So obviously we have to look for the average product of labor first. So the formula we know, we said that the average product of labor is Q over L. And then we are going to have our Q. Remember, our Q is 15L squared from the statement there, and then minus 0, 0.5 L cubed, and then over L. So remember I said that if you have a L here at the bottom, you split it, you give it to 15L squared, and also you give it to 0, 0.5. So that's what I'm going to do. So I am going to have 15L squared over L. So it deserves this L, and then minus, minus, and then I have 0.5 L to the power of 3, sorry, L cubed, then over L, and then after this, we divide. Remember, I said that, I'm going to write it here also so that you can understand. If I have, just going to make example with 1, if I have L squared over L, this is the same as L times another L over L. L squared, it means it's 2 L's. Then here, my answer is going to be, these two are going to cancel. This L will cancel this one. Then it means that my answer, I'll be only left with L. I'm just doing this so that you understand where I get my answers. And then now it means that L squared divided by L, so I'll have 15, then L. And then 0.5 L to the power of 3, it means I have 3 L's. So when I cancel, I'll only be left with 2 L's. So I will have L squared. And then they said that they said when for the first 10 units, so it means that now we are going to do what we did before. So we are going to say when now our L is 10, we are looking for the average product labor. So this means that when our L is 10 units, then it means that therefore our APL is going to be equals to 15. Wherever I see L, I put 10. So this will be 10. And then this is minus 0.5. And then it's 10 to the power of 2. Then can you please assist with the calculator?
100.
100. Okay. So therefore, this one means that the average productivity activity unit of labor is 100 units. Of output for each of the first 10 minutes of labor employed. Yeah, so average productivity per unit of labor is 100 units of output, which is this, for each of the first 10 units of labor employed. So yeah, that's under your average product and marginal product labor. Then now we are going to go to optimization. Tobani? Yes.
Yes, ma'am.
Yes.
Sorry, I just wanted to ask if you see the formula APL is equal to Q over L. And then if I just substitute with the value of Q, that 15L to the power 15L squared minus 0.5 L cubed over L. If I just substituted L with 10 from the second step, I will be wrong.
Yeah. Oh, no. You won't be wrong. And you also divide with L.
Or I won't divide with L. I'm gonna just substitute with 10 instead
No,
of
it's
L.
wrong.
It's wrong.
No. I'm saying if you substitute from here,
Yes.
the answer will be the same. You'll still get 100 here,
Oh,
right? Yeah, it's the same thing. Yes. So here we're simplifying.
Oh, sorry. It's just that I don't have calculator here. I'm in the class.
Oh,
Thank you.
okay. All right. Okay. And then now we go to optimization of economic functions. So we did optimization before. So this is just a repetition of the things that we did. It's just that now we are applying them. But it's the same thing here with optimization. So remember we said that when you're optimizing, you firstly have to look for your turning point. After you get your turning point, and then you solve for the variable. For your Q, take your Q, put it in the second derivative to tell us whether you are maximizing or minimizing profit. We did this. So if I want to maximize the turning point, I find the second derivative. And if my answer gives me a negative, then I know it's a maximum. If my answer gives me a positive, then I know it's a minimum. So, and then I said to determine whether turning points are minimum or maximum points, substitute your x value into the second derivative. That's if it's possible to substitute if there's still x in your equation. So now let's look at this example so that we can understand. We're doing the same thing that we've been doing here. So here they're saying given the demand function, so you're given the demand function, and then they're saying write down the total revenue and the marginal revenue. We're doing the same thing again here. So I try to divide these questions so that you can understand, or else it could have been one question. So remember, total revenue is equals to P times Q. We did this during our second or first lesson. So now we're going to substitute. Our P is 100 minus 2Q, then times Q. And then now we multiply. This is 100Q minus 2Q squared. That's your total revenue. Your total revenue. And then after you get your total revenue, you get the marginal revenue, you derive. So the marginal revenue is going to be called the derivative with respect to Q of my total revenue, which is 100Q minus 2Q squared. So I'm going to do this again. In case you didn't get how to derive, I'm going to repeat the same thing that I did. 100Q is going to be 100. I said that there's always a 1 there, but we don't write it. There's a 1 here. So this will be times 1. And then this is Q. And then to the power of 1 minus 1. I am only doing this so that you can understand. And then minus, then 2 times the exponent 2. And then Q. And then to the power of 2 minus 1. We always minus the 1 from your exponent. And then now we can solve. So we are going to have 100 and then Q to the power of 0. And then we have, sorry, I need to enter this. Okay. Okay, so I am going to have, okay, I'm going to have 100. This will be 100Q to the power of 0, then minus 4, because 2 times 2 is 4, to the power of 2 minus 1 is 1. Then 100, we said Q to the power of 0 is 1, so this will be 100 minus 4Q. That's our marginal cost. Sorry, marginal revenue. Sorry. Marginal revenue. And then now we move on to number B. So we're doing the same thing again here. Number B says calculate the number of units which must be sold to maximize total revenue. So remember, to maximize, minimize, you start by first looking for your turning point. And the turning point you need to derive. So we start first. Let me just write it here on the side. So when we maximize, step number 1, we find a derivative. So I'm just going to try number 1. We find the derivative of, let me say with respect, derivative of total revenue and equate it to 0. And then step number 2, we are going to solve for Q. I'm just writing this so that you understand every time they say maximize. So we are going to solve for Q. Solve for Q. Just doing this so that you can understand. We're going to solve for Q. Solve for Q. And then after that, we find the second derivative. And then we find the second derivative. Step number 3, we're going to look for second derivative of total revenue. So let's see. And then we do the greater than and less than. So let's see if we can do this. This is when you are maximizing. I hope that's what I did last time. Okay, let's see if that's correct. Step number 1, we derive. So I'm going to say number 1, I'm going to derive and equate it to 0. So it's the derivative of my total revenue. And then I equate it to 0. So let's do that. So the derivative of our total revenue, we got, not total revenue, it's marginal. Sorry. I'm sorry, it's marginal revenue. Thank you. Yeah. It's marginal, sorry, not total. No, it is. Yo, why am I changing my things? It is total revenue. Sorry, the derivative of total revenue is marginal. So it means that I'm going to take this and equate it to 0. So this means that I'm going to say MR is equals to 0. My MR is 100. Remember, MR is the derivative of total revenue. So this will be 100 minus 4Q is equals to 0. Yes. So remember, this is the same as marginal revenue is equals to 0. Before I forget, let me write it again. This means that because the derivative of total revenue is your marginal revenue. So you're going to take your marginal revenue and equate it to 0. So I'm going to do that, yes. So I'm going to say, therefore, I'm going to say 100 minus 4Q is equals to 0. Then after that, I solve for Q. I'm going to take this to the other side. So this will be negative 4Q is equals to negative 100. When you change a number to the other side, it changes the sign. And then remember, 0 plus negative 100 is still negative 100. And then now I'm going to divide both sides. So I'm going to have 4Q. Please mute your mic. And then I divide both sides by negative 4 because I want my Q. Please mute your mic. And then my Q is going to be, what is my Q? 25. 25. And then after I get my Q, now I can find the second derivative. So it means I already did step 1 and 2. So I already did these 2. So that's step 1, then step 2. Actually, these 2 are the same. So my step 2 is somewhere here because I'm solving already. So I already did step 2 here. I was solving for Q. And then the last step, I find the second derivative. So second derivative, so it means I'm going to derive twice. So how are we going to write it? I can say second derivative. So this is prime. So remember, our first derivative is 100 minus 4Q. That's the first one, right? And then now the second one, now my second derivative, I'm just using the prime. I'm using this comma here on top. So this is prime. I am going to have, this will be 0 if you remember. This is 0. The derivative of a constant is 0. And then this will be minus. And then let me do this. It's 4. Then remember I said there's a 1 there. So it's 4 times 1. And then q to the power of 1 minus 1. 1, then minus 1. So I'm deriving the derivative, the second derivative. First derivative, we got this 100 minus 4q, which is this. And then now the second derivative, I derive this. I'm deriving 100 minus 4q. So the derivative of 100 is 0 minus the derivative of 4q to the power of 1 is going to be 4 times 1, then q to the power of 1 minus 1. Then I am going to have negative 4 times 1 is 4, then q to the power of 0, which is going to be negative 4 because q to the power of 0 is 1. So because we said that my second derivative is negative, we said that here. We said that if your second derivative, d squared, it means the second derivative is negative, less than 0, meaning if it's negative, then our turning point is a maximum. Then the question here was saying that calculate the number of units which must be sold to maximize. Okay, I'm answering. Okay, am I answering number B? Okay, no, I'm not answering. Yeah. So because this answer, the second derivative is less than 0, it's negative, then it means that our profit will be maximum, right? This is less than 0. So therefore, our turning point is maximum. So the question, they wanted to know the number of units which must be sold to maximize the total revenue. These are the ones, right? Yes. So these are our units. So this is 25 units. Calculate the number of units which must be sold to maximize. These are the number of units. Okay. Here I was proving if it's maximum. I don't think this was necessary, but anyway, it's fine. Now let's go to number C. I think I answered more than what I should. All right. So number C says calculate the maximum total revenue. So remember we said that our total revenue will be maximum when 25 units are sold. So it means that, remember, don't forget that our Q is equals to 25 units. So if our Q is equals to 25 units, for us to maximize, you must always substitute into the original. Don't forget that the original function of total revenue is this one. You substitute into the first function, which is TR is equals. You always substitute into the original, please. Always substitute. Let me just write it here. And B, always substitute into the original function. Original function. So our original function is TR is equals to 100Q minus 2Q squared. So when we want to calculate the maximum total revenue, so this will be 100 and then times these units, which is 25, and then minus, then 2, and then this will be 25. It's going to be what? 250. Yeah? What's the answer?
1,250. 1,000.
Oh, 1,250. Okay, the R is not really important. Okay, yes. So it means that when 25 units are sold, total revenue is a maximum at 1,250. That's what it means. 5 units sold total revenue is a maximum. Sorry, maximum at, yes. So please don't forget that you must always substitute into the original function every time when you're looking for the maximum total revenue. All right, now we go to number 2. Number 2 says, given the demand function and total
Maseko.
yes.
Sorry, my hand is up.
Oh, I didn't see it. Sorry. Yes.
No stress. I wanted to find out, the questions that are in this exercise that you're doing, they are quite short. And sometimes when the exam comes, it comes in stories. And that usually throws off a whole lot of us. Well, let me speak for myself. When the exam come, will it come in the same fashion as it is presented here? Or will it come in a form of company A or XYZ company wants to do this and all of that? Because we need to understand also the storyline, I feel. And if we've missed the storyline, or if we miss maybe the contextualization of these calculations, we may not even understand what is requested of us. Yet we know the answer, or rather we know the processes, what we should follow. But because it's presented to us, the question in a manner that is a storyline, most will not even understand what is requested of us. So I don't know how we can make it such that it mirrors what a practical situation will be in an exam or any given situation. Because if we're just given this, we are unable to apply it in a practical scenario. I don't know if it's something possible. Yeah, that's one. The second one, Maseko, is you mentioned that marginal, I think you said marginal revenue, or the derivative of total revenue, or total revenue is marginal revenue. Is it the same principle as far as total cost? The derivative is a marginal cost. I just wanted to understand that relationship. Yeah, I would appreciate your contribution in that. Thanks, Maseko.
Oh, thank you. Yes, it is the same. Sorry, I'm starting with the last one. Yes, it's the same. It is the same. Marginal total cost. Can you please mute your mic? Marginal total cost is the derivative of total cost, and then marginal revenue, derivative of total revenue. And then with regards to stories, I think when you are about to write your exams, we are going to have a revision, as a class, what do they call it? Yes, where we revise. So I'll make it a point that when we revise, I put the stories, or let me say for my next lessons, I will look for questions that have stories so that can make sense. I think moving forward, I will try to look for questions that have stories so that everything can make sense. I hope that's okay.
Thank you, Maseko.
Okay, and then before your exam, we are also going to have a revision, but that won't be recorded. So you have to just attend and take screenshots and. But it won't be recorded. Yes, Oka? Oka, yes. Yes, you can ask. All right, I think you muted yourself, so I can't hear you if you are talking. All right, Tobani, you can ask. Okay, if not, okay, let's.
No, we can continue, ma'am. I'm fine.
Okay, thank you. And then we have number 2, it says, given the demand function and total cost function. So we have that. They're saying write down the total revenue. So we know that our total revenue, again, is the same thing. Total revenue is equals to P times Q. And then they're saying, oh, yes. So our P, we have 50 minus 2Q, and then times Q. And then this will be 50Q, and then minus 2Q squared. And then now we go into number B. Number B says how many units should be sold to break even. So we know that at break-even point, your total revenue is equals to your total cost. We did this again when we started. So here I just put this here so that you can understand. Please mute your mic. Thank you. All right. I just put this here. So we know that to calculate to calculate our units at break-even point, we need to equate. So we are going to equate our total revenue at break-even is equals to total cost. Our total revenue, we have 50 Q minus 2Q squared, then is equals to our total cost. We have 160 plus 2Q. It's from here, this one. So now, because of our equation has a square, for us to calculate the Q, we need to use the quadratic formula. This is why you learned this quadratic formula. We are going to use this. Okay, let me just edit this and write Q so that it's fine. Okay, so because of this square, we are going to use the quadratic. Because of the square, we are going to use the quadratic. So because of this square, I'm just going to write it here. We are going to use a quadratic. That's why we're using a quadratic. But before we use our quadratic, our equation must be in this form. It must be ax squared. You cannot use the quadratic if you don't have these three. It must be ax squared plus bx, then plus c. Let me use the q, not the x. It must be aq squared plus bq, then is equals to 0. You can only use that if your function looks like this. So we are going to take everything to our left-hand side because the right-hand side must be 0. So we are going to have 50 q minus 2q squared. And then now we move the 160 to your left. It's going to be negative 160. Then you also take 2q, you move it to your left, it's going to be minus 2q. And then everything is equals to 0. Again, it must be in this form, so I must have 3 terms. So I'm going to take I'm going to answer first, okay? So I'm going to have these two are like terms. These two are my like terms, this one and this one. So I am going to have negative 2q squared, and then 50 minus 2q is going to be positive 48q. And then I have minus 160. Then this is equals to 0. So now you'll see that my function is in this form. So now I can see my A is negative 2, my B is 48, and then my C is negative 160. So I'm going to do that. So my A is going to be negative 2, and then my B is going to be a positive 48, and then my C is equals to negative 160. Yes, Mapelo, I see your hand. Mapelo or Mapelo, yes, but yes, I'm sorry. Yes. I can't hear you. You can ask. Are you asking a question?
Can you hear me?
I can hear you, but yeah, you can. Yes, you can ask.
I'm sorry to disturb you. Oh, isn't a negative and a negative is a positive? So how is it that it's now a negative 2 squared again?
A negative and a negative. Which negative? I only took this, I put it here. I didn't do anything to negative 2. The only people that I touched, it's 50q and negative 2q. Yeah, those are the only things that I touched. I didn't do anything. Negative is still negative. I didn't move it to the left. It's still negative 2q. Can you see? The only thing that changed is it's 50 minus negative 2q, which is 48. We are adding like terms. Is it fine?
Okay.
Okay. Yes, I'm not multiplying anything
Okay.
here. All right. Yes, someone's hand was up.
Ma'am,
Sorry, ma'am.
Yes.
can I ask then this quadratic equation of minus 2, which is a equals to minus 2, right? The thing that I want to ask is that in the quadratic equation, don't we have to divide it by minus 1 so that a can be positive? Or is it only done in the mathematical?
No, you can't, but it's not going to make any difference. Even if you you
Yeah,
divide it by negative, we're
yeah.
going to get
Everything
both
by
gonna,
negative, yeah?
yes, we're gonna get both of us are gonna get the same answer.
Okay, thank you.
Yes, yes. So you'll have positive, negative, positive. We're gonna get the same answer. It's going to be the same. All right. Who else wanted to ask? I had a
Sorry, ma'am. Can you hear
voice.
me?
Yes, I can hear you.
Do you have to do this long method or could you just factorize?
You can factorize. Remember, some of us didn't do pure maths, so I'm just finding the easiest way for us to solve for Q. So you can factorize if you can. So you
Okay.
can divide everything by 2, and then
Yeah, and
you'll have your
then
Q squared. Yes, then plus
yeah,
24. Then yes, you can.
24. Okay.
Yeah.
Thank you, ma'am.
All right, you can. I'm just doing this long method for people who didn't do pure maths or people who haven't done maths in a very long time. So I'm just trying to find the easiest way to do this. We can factorize. So I'm just using this quadratic formula for some of us. All right.
Sorry, can I just ask one more question, ma'am?
Yes.
So one thing I realized is that, I wanted to ask, would it be possible for us to do more? Not that these questions are just plain, simple, but I was hoping we could do more difficult questions in terms of, especially when it comes to like some of the questions we get in our activity. I found that like our class sometimes doesn't really entail, that many difficult questions to go through. So yeah, I was hoping we could, I don't know how you feel about that, or because I noticed that in the study guide, some of the questions are quite different to what we actually do in class.
Okay. I always
Mm.
try to align my questions with the ones on your study guide. It's just that the activities are too many, so I can't do like for instance, this topic it had, I think activities have like 5 questions and then they have sub questions. So
Yeah.
maybe you have like 15 years. So I try to just
Okay.
pick from the questions that you get, but I will try to find more difficult questions
Yeah,
on
not
your
to
request.
just make
But
sure
if it,
that,
yeah,
I'm
I
not trying to
address,
make sure that
yeah.
we get all the exam questions or test on questions, but like it'd be nice to just see like extremely tough questions to kind of rack our brains and make us think in different ways, you know?
Okay, no, I'll try. I
Thank
will
you,
try
ma'am.
to look for them. Yes, thank you. I think it goes with someone said I should look for questions that are real life, like real life problems. Yes, questions like that. So I'll try to look for those questions.
Sorry,
I will try. Okay, yes.
can you hear me?
Yes, I can hear you.
Just to go on what he said earlier, so I didn't do pure math, and doing some of the activities in the study guide, they're very difficult. Some of them have factorizing, some of them have factoring.
Yeah, you see,
I have no
this is
idea how.
why.
Yes, that's why in my class I try to use the easiest methods and I try to elaborate on the examples because the examples on your study guide they don't have questions. It's just an example with an answer. So I try to come up with the questions that are closer to the activities that are in your study guide. So you see here they were factorizing. So I chose to use the quadratic method because I realized that not all of us know how to factorize. So I try to look for the easiest way to do so that you can be able to do your activity. So when I'm done with this, you can go to your activity and see if they you are able to answer. And then also please don't forget that we have our AAs, Agent Academics. They can also assist with classes during the day. You just have to contact them and then they'll try to make it easy for you. Is that fine? Please do talk to them, send them emails, ask questions, they will assist.
Just to ask, what is that AA you just mentioned, ma'am?
What do you mean? What is, they are lecturers also. They
Oh,
are
okay,
working
ma'am.
with me. Yes, they are working with
Okay.
me. They are not
Okay.
tutors. They are also lecturers assisting with my
Okay.
module. Yes.
Okay. So we can email them questions and
Yeah, you email, but remember you have to try a question before you ask the question. You can't
yeah,
just
of
give them
course.
questions
No, of course,
without.
of course, of course. Yeah.
Yes.
No
All
problem.
right.
Thank you, ma'am.
Okay. Pleasure. Okay. So they're saying how many units should be sold to break even. So every time you have to calculate units and you realize that your function has a square, please, you are going to have to use the quadratic. And then when you use the quadratic, always make sure that your formula is in this form. Your function is a number with a q squared plus a number with, please mute your mic, a number with a q, then plus c. Can I please finish this question and then I'll answer your questions, Fiso? Can I please finish this one? And then now my a will be -2, my b will be 48, and then my c will be -160. And then now we are going to solve. The plus or minus, it means you have two answers. A square means you have two answers. That's why we are using a quadratic to solve. This square, it means you're going to have two q's, 2 units. So I'm going to have, can someone please assist with the calculator? The first one, please put a minus, the other one a plus. Let me just rewrite it. So we're going to say q is equals to, I'm just doing this for people who, okay. All right. Okay, can someone do this for me under the square root? This is -4 or q, you're going to have two answers. Q is equals to -48, and then this is minus, then the square root, and then -4. What is 48 squared minus 4 times negative times negative? Then this will be, what are my final answers?
Q is equals to 20. Q is equals to 20.
20. Another one?
Q is equals to 4.
4.
Q is 4. So those are our answers.
Ma'am, I
So
think
to
you
break
swap them
even,
around. The plus one is the 4, the minus one is the 20.
okay. 4, 10, 20. All right. So those will be your answers. Fiso, your hand was up.
Yes, hi. I got a different answer because I think I did it on my own and I made a mistake. I'm not sure. Maybe I think they're at the top on the first calculation where there's 50q minus 2q squared equals to 160 plus 2q.
Mm-hmm.
Instead of bringing the 160 plus 2q on the left hand side, I plus did the 160 plus 2q, and then it was 162q. And then I brought it on the left hand side, and then I said 50q plus 2q squared minus 162q equals to 0.
Okay, so we can add 160 and 2q because they are not like terms. So like terms, it means that the numbers must have the same variable. So if you can check, this is q squared. The q squared is not the same as q because q squared, it means we have two q's. There are two of them. This one is one of them and then one of them. You can only minus the ones that have the same variable. So you can add or minus the 160 with the 2q. Why? Because your 160 doesn't have a q. That's why I marked them. These are your like terms. So we can only do that because they are like terms. These two are my like terms. This one and this one, they are like terms. So you can add 160 with 2q because 160 doesn't have a q. So like terms are like this. So your like terms are the numbers that have the same variables. Like terms is like xy plus, maybe let's say 3xy plus 4xy. The fact that they both have xy, we're only gonna add numbers. My answer is going to be 7. I think I did it the last time. The answer would be 7 and then xy. You cannot add the numbers that don't have the same variable. So this will be 7 xy. So 3xy plus 4xy is going to be 7xy. You cannot add, if I have 3x, maybe let's use a q. If I have 3q plus 5, my answer will still remain 3q plus 5 because they are not like terms. Not like terms. They're not the same. Is that fine? Like terms, they have the same letters. So because 160 doesn't have a letter, it's not the same. And 2q squared is not the same as this one with the q. These ones, the q's are two. There are two of them. This one is only one q. I hope it's fine. All right. Let's move to number C. I hope I make sense. Okay. Let's go to number C. Number C says write down the equation of the profit function. And then is it possible to find the maximum profit? So if it's possible, we'll see. If not, we'll also see. So for you to find the maximum profit, you know, you have to do the turning point, differentiate turning point, and. We do the same thing again. So now let's start with the profit function first. So we know that profit is equals to, we know that profit is equals to total revenue minus the total cost. That's the formula for profit. And then our total revenue, we got 50Q. Don't forget, our total revenue is 50Q minus 2Q squared. And this will be minus our total cost is 160 plus 2Q. I took this from here. Remember, I'm still doing the same thing. We are here on number 2. Total revenue, and then total revenue, total cost. And then this will be 50, we're removing the bracket, minus 2q squared. This minus outside the bracket, it always affects everything that is inside the bracket. So here we are going to have, it's going to be a negative 160. The minus outside the bracket always changes the sign inside the bracket. So this will be minus 2q. And then we are going to have now like terms. These two are like terms, like I said. These two are like terms. This one and this one, they're like terms because they both have Q. Q makes them the like terms. So we are going to have 50Q minus this. We're going to have 48.
48
Q. And then this is minus 2Q squared and then minus 160. Please remember, this is an expression. It's not an equation. My profit, my P profit function is that. That's my profit function. This is a profit function. Okay. Profit function. And then now we are going to find the maximum. We want to see if it's possible. Then we are going to see if we can get a maximum profit. To get a maximum profit, step number 1, you must differentiate your profit. So we're going to start step number 1. You differentiate. We are going to say the derivative with respect to Q of P must be equals to 0. And then now we derive. So the derivative will be, this will be the derivative. Our profit is 48Q minus 2Q squared minus 160 equals to 0. Then now we do it. You must always go with the 0. You must always go with the 0. So we are going to have When we derive 48q, I'm going to do it again. I'm going to put a bracket and say 48. Remember, I said that there's a 1 there on your q. There's always a 1 here. So this will be times 1. And then q, then to the power of 1 minus 1. 1 minus 1. And then this is minus, then bracket. Now we derive the 2. This will be 2, then times that 2. And then q, and then to the power of 2, then minus 1. And then this is minus. The derivative of a number is 0. I'm going to say it's 0. Then you must write the equals to. And then after this now, we write the answer. So this times it's 48 q to the power of 0 minus 4 q to the power of 1. Then the 0, I'm not going to write the minus 0. And then q to the power of 0 is 1. So this is just 48 minus 4q is equals to 0. And then now after this, we know we have to solve for q. So I'm going to take this to the other side. I have a negative 48q. And then this 48, negative 40, sorry, negative 4q. And then the 48 is going to be a minus 48 because I moved it to my left-hand side. And then now I am going to divide by 4 both sides. Then I divide by 4. When we divide by 4, negative 4, divide by negative 4, then it means our q is going to be, what will be our q?
12.
Our q is going to be 12. So now it means that our profit, let's see if it's going to be maximum at 12. So now we have to find maximum profit. So we are going to take this 12 and substitute into the original. So to see if it's a maximum, remember we derive. So to see if it's a maximum, we find a derivative. So we can do that. Second derivative, number 2. Okay, let's see. Let me go back to my steps. I'm sorry. So I found my q. Sorry, I'm just going back to see everything. Okay, I did solve for q. So 1, 2, I did. Then I find the derivative. Okay. So that's step number 1. Step number 2 is this one. I did solve for q. So this is sort of step number 2. Then step number 3, I find the second derivative. So second derivative of profit, we can do 2 here, 2 there. Second derivative of my profit is going to be, I am going to have, what's this? Profit, this is my profit, ne? Second derivative, I have to take this. So let me write the first. Let me first start with the first before I do the second derivative. Okay, so my first derivative, let me just do this. First derivative, my answer was 48 minus q, 4q. That's my first derivative, 4q. Now, if I look for my second derivative, this one will be 0 because the derivative of a constant is 0. So this is going to be 0 and then minus 4 because this is 4 times 1, then q to the power of 1 minus 1. I'm just doing this. So this will be a negative 4q to the power of 0. Then this will be a negative 4. So because I got a negative 4, it means this is less than 0. So I have a maximum. So therefore, it's a maximum profit. I will make a maximum profit where my Q is 12. So let's see if we are going to find the maximum profit. So it means that therefore, maximum profit at 12, I'm going to have P wherever I see, because my P original is 48, Q minus 2. Remember I said you must always substitute into the original. So I will have 48, and then my Q is 12. And then this is minus 2. Then my Q is 12 to the power of 2. And then minus 160. Can you please assist with the... So we are going to have, because they were saying, if is it possible to find the maximum profit? So it is possible. We saw that when we were deriving, we were going to get the maximum profit. So can you please assist with the calculator? So that's our maximum profit. Please assist with the calculator.
That's 128.
It's 500 and, huh?
128.
Okay, so it's 128. All right, so that's how we maximize profit from deriving. Firstly, you find the first derivative, solve for Q, and then after you get your Q, check if it's a maximum or minimum profit. So this is maximum. After we know that it's a maximum, then we can calculate. So here they were just saying, check if it's possible to find the maximum profit. So it is possible to find the maximum profit here. That is that. Can I please stop the recording? Then you can ask questions because, yeah, it's too long. So you can ask questions. I will do Monday we don't have a class. I will do the recording. I will record the class, teaching myself, and then I'll see. I'll try to record the